Hello everyone, good evening. So before we look at more examples on the center of mass of a rod, let us recall the formula. X bar is equal to the moment of mass of the rod divided by the mass of the rod. And during our class discussion, we have derived the moment of mass. It's given by the integral of x times the linear density rho of x. This is the linear density from 0 to L, where L is the length of the rod, while the mass is the integral of the linear density from 0 to L. Now let us look at this example. We have a rod. The length is 6 meters. So let me note that here. The length is 6 meters. And another information is its mass. The mass of the rod is equal to 24 kilograms. And there is also an information given about its linear density. So the linear density, according to the problem, its rho of x varies directly as the square of the distance of the point from one end. So meaning, since it varies directly, it's a product of a constancy k and the square of the distance, so that is x squared. So for a particular x, the linear density is given by kx squared. Now, to find the center of mass, we need to know the linear density. So we have to solve to find rho of x. In other words, find the value of k. So to do that, with these three information, we can actually use the formula for mass. Let us do that. The mass is the integral from 0 to 6 of the linear density. So this is the mass. In other words, the integral from 0 to 6 of kx squared is equal to 24. The mass is 24. Now, k is a constant, so I can factor that out. X squared dx equal to 24. Integrating x squared, we get x cubed over 3. Evaluate from 0 to 6 equal to 24. Now, evaluating, we get 6 cubed over 3 minus 0 cubed over 3 equal to 24. 6 cubed, 6 times 6, 36, times another 6, that gives us 216 over 3 equal to 24. And 216 over 3 is 72. So I have 24 over 72. Therefore, my k is 1/3. Okay, this is my k. Since that is my k, I already have my linear density. Therefore, rho of x is equal to 1/3 x squared. This is because k is 1/3. Now, we are now ready to find the center of mass. The center of mass is the moment of mass divided by the mass of the rod, which we already know to be 24. So what we only need to find is the moment of mass. So let me write that here. Moment of mass. It's given by the integral from 0 to 6 of x times rho of x, which is 1/3 x squared dx. Factoring out the constant 1/3, so I have x cubed dx. Integrating, we have x to the 4 over 4. Evaluate from 0 to 6. So 1/3, 6 to the 4th over 4 minus 0 to the 4 over 4. What is this? So 1/3 times 6 to the 4th is 6 times 6, 36, times another 6, 216, times another 6, that is 1,296 over 4 divided by 3, we get 432. 432 over 4, and 432 over 4 is 108. So the unit is kilograms meter. This is the moment of mass. Therefore, this is 108 kilograms meter. The mass is 24 kilograms. So therefore, the center of mass is given by 9 over 2. 9 over 2 meters, or this is 4.5 meters. This is the center of mass.